Okay, so this is very kind of taking off from where I left off last time, where I discovered this web development nirvana with ClojureScript, and now I'm telling you that that's not quite the final thing.
Is this it?
Well,
Have you
so
found it?
what has anyone heard of Elm? I suppose we mentioned it last time. Some people have heard of it. What it is a programming language first and foremost, a pure statically typed, strictly functional programming language. So you can't do any kind of mutations or anything like that. All the state is immutable, and there's no backdoors to make it mutable, like there are in Clojure and there are in F#, etc. So it really sticks to its guns as a language, which is good. But it's specifically designed for building websites, so it transpiles to JavaScript. For the moment, they may have plans. I know they'll have plans for server-side stuff. And then, so last time I was talking about ClojureScript with this reagent layer on top and this reframe layer on top of that, which gives you this reactive style of programming. This is the same, but it's kind of much more embedded into the language itself. There are many different flavors of functional reactive programming, as I learned when talking to the inventor of Elm on Twitter. He was talking about classical functional reactive programming and event-driven, and apparently Elm is a particular flavor of arrowized functional reactive programming. I made the mistake of asking Christina's question about whether he suffered from time and space leaks, which is a time and space leaks are classical problems of functional reactive programming, and he was, I think, delighted to be asked. It's a bit too much. I don't really understood the answer, so don't ask me that. It's fine is the answer. So we care about this for the same reason we care about the ClojureScript thing, in that it solves the JavaScript problem in the same way that ClojureScript, in my opinion, solves the JavaScript problem. But then further, it solves the ClojureScript problem, which, so in a few cases in ClojureScript, you'll still find yourself chasing nils around, working out why your data is not in the shape you thought it was in, and you can still find buried at the bottom of all this lovely functional code is an atom, a Clojure atom, and there's just normal mutation and state management going on at the bottom of this secretly. So it's not totally without problems. So what you get in addition with Elm is this really nice type system and compiler. It's similar to F# in terms of the type system, and it's really difficult to make a mistake with it. Well, it's easy to make a mistake when you're writing the code, but it's difficult to make a mistake at runtime in it. And that's one of its selling points. No runtime exceptions. That's one of its headline features on the website. It's just not possible. It's not possible to cause a runtime exception by the code you've written. Obviously, the browser can shit itself or whatever. So that's a really big deal. And I've been playing around with it for a while, written stuff sort of similar to the sort of things we write, and I've never once seen it throw any kind of runtime exception. It does appear to be true. I've had plenty of time spent just going, why the fuck won't this compile? But that's probably the right way around. So given the nature of the language, you get certain guarantees with it, and it does make life easier. So for example, if something's going wrong in your code, if something weird is happening, you can simply look at the signature of a function, and if it returns a string or something, or if it returns some other kind of type that isn't an effect of any kind, you can say, nope, it's not that. It can't possibly be that. That function literally cannot do anything untoward. So it really makes finding out what's wrong when your code is misbehaving much easier, because you can disregard a whole load of it because you know it can't possibly be causing that sort of problem. I've found that pretty useful when writing it. Why do we care? Part 2. This is a benchmark that you can run yourselves on To Do MVC, which is that site where they write this non-trivial but not too complicated web app with all these different frameworks. And as you can see, Elm does pretty well on that. It even beats Om, which is a sort of probably most similar kind of thing to what we were talking about in ClojureScript. And obviously the reason it can do this is because of the immutability, and most of the other ones that I've talked about before are just wrappers around React. This doesn't use any other frameworks at all. It doesn't use React. It has its own virtual DOM implementation, so it kind of works in the same way, but it evidently does it a bit better. It's just a benchmark, but this is an apt quote from one of my favourite Twitter curmudgeons, that this is the other reason that I care, because I think that we all spend a fair amount of our time chasing our tails because of JavaScript. We don't really need to anymore. So I'm going to explain a bit about how it works, and most of this is just like functional reactive programming concepts, but there is a sort of Elm architecture which is placed on top of it, and if you follow it, life is easy. If you slightly don't follow it, then you get very confused. So the most fundamental thing to understand is the signal. The signal is just a sequence of values that vary over time. They can be of any type, and that's the building block of everything. So an example of a signal in a web development context might be the user's mouse position or something, or the window size, or what buttons they've clicked, or what keys they've entered. But the whole thing will be recorded from when you started the site to right up to the current moment in this set of signals. So everything that's happened is there.
They don't call them events, they call them signals deliberately.
Yes. Because they're not events, they're a signal of events. So it's two slightly different things. And so that is the state of your application. There is no other state, because nothing else happens. A signal could be an external signal, of course, so you could have a web request happening. But ultimately, the whole state of your app is recorded in these signals, and that's all the state you need. You don't need to capture it anywhere, and you don't need to mutate it because it's all there. It's a bit like event sourcing. You recognize the sort of concept. So then, in a typical Elm component, which themselves can be stacked up into an Elm app, you would take these signals, these raw signals, and you would have a step in which you combine them in some way and map them to another signal, but a signal of actions, and the actions being a sort of more business-oriented description of what has happened. So a button click would be like a raw signal, and you might translate that, depending on what was clicked, into something that your app understands, like search initiated or something. So after that stage, you've aggregated all your signals, and you've got this stream of actions that your component or your app cares about. So then the next step, you've got this long stream of actions that you care about, and you've got a model, what you would call a model, which would be the sort of state that your app is currently in. So basically, the next step is to fold into the past, and that's what this fold P is all about. Fold being another word for reduce. So basically, you're just going back over all of these actions and just aggregating them into the current state of your model. And to do that, you fold the sequence of actions through an update function with an initial model. So you're going all the way back into the past from when your app started and just folding through all the actions, passing through the current state of your model for every iteration. So you just need an update function which takes the current state of the model and the current action that's coming in and just returns the new model. So there's no mutation involved, it's just a reduce over the stream of actions.
So you're suggesting that you start from now and you go backwards to the beginning, but isn't it the other way around? Don't you?
Yeah, sorry, yeah, you start at the beginning. Yeah. How it works under the hood, it doesn't really do that, but yes, that's the concept. So that yields a signal of models, so a signal of the state of your application rather than a signal of actions. Then you can take that signal of models and just pass that into your view, which is the bit that takes the model and just displays it however it looks. Which is cool.
So does that imply you can have more than one model? I mean, you've got your signals turn into a list of actions.
Yeah.
Does that turn into a list of models?
Yeah.
Signals and models. Okay.
Yeah. So you can move backwards and forwards in time.
Oh, I see. But you've only got one model for the current point.
Yeah, you're looking at the current value of the signal at any one time, but you can move backwards, which is cool. It's very good for debugging, if you need to, which I actually never have really. So then, to complete the circle, then obviously inside your view you'll have normal things like event handlers and button click handlers, but what they'll do is basically there's this final concept called mailboxes, and a mailbox is just a thing that has a signal and an address. So basically you write a message to its address and it exposes the signal of all of the messages that have been put on its address as its signal. So it feeds back into the beginning. So if you were to click a button, it's just going to be translated into a button click signal or directly into an action signal, depends how you write the code, and then just go through this process again. So it's quite similar to the reframe style in that you're firing off messages and then just re-rendering your view based on the current state of the model, but the extra guarantees of the language and the nature of the language make it a lot safer. Okay, so I thought I'd just go and basically do a demo now just to show the building blocks of the architecture. I'm not going to build anything complicated because I just want to demonstrate these core concepts as they would be done normally. So we're going to do this online, hopefully. So if you go to the Elmlang website, there's this try bit where you can just write your code and see the result straight away. So let's just dive in. To get anything to happen in terms of a web app, we will need a couple of things. We will need the HTML attributes. This is just fairly familiar stuff of how to include bits. These are just packages that come with Elm. And then every Elm program, top level, needs a main function. I'm not going to agonize over the syntax of the language too much because it's quite simple syntax and it just sort of gets out of the way mostly. And you don't really need to worry about it too much. But this would be the hello world of, not the hello world of Elm. hopefully. Yeah, so there we go. And if we look at what that actually creates for us, it's pretty much as simple as can be, what you'd expect. So we'll have I'll try and follow the pattern set out in that picture. Let's go full screen. So we will need a model, we'll have some sort of concept of an update, and we'll have some sort of view, and we'll have a bit of wiring. So the view function, this is quite similar to the reagent stuff in a way, that you just have this, all your HTML is created in line in the language. So if I wanted to do the same sort of hello world here, the way it works is that first thing's the function name, second you provide a list of attributes, and then you provide the actual content of the element you're trying to create. I can't spell world. So then if I just plug that in here instead of it's the same. Okay, so what we will actually want to create is not that though. I'll do some. I still don't really know how to lay things out in this language. The advice on how to do that is a bit weird. So if I did blue clicks. Try and make it nice, but now I am going to cheat slightly here, okay, because it's a bit tedious writing this stuff. I'm just going to get a bit of style. Just to make this quicker. So this is just another example of how you can, how you would do inline styles. You wouldn't do this obviously, you put in a style sheet, but because we're inside this online editor, it's easier to just pick this up and do it like that. And then you can just type that in here. Press the wrong button. Okay, beautiful. But doesn't do anything. Okay, so we're going to need some sort of model to track the clicks. So I'll create a type for that. And the reason this is an alias is because this isn't really anything other than a record type, which is just a set of name value pairs. So I could just say blue clicks, and I'm going to say that that's an int. Make sure we're still okay. And then I want to create an initial model. So this is the only real state that I'm going to have in the app. I can use the name of my type as a constructor, so I'm going to call it like that. And let's just, sorry?
Initial.
I'm just going to fill in the other ones as well.
Still typing.
Fucking typing. Initial, there we go. So then I can do that. Now you can put type annotations on your values and functions, and probably you should. Like you can see there on that button style one, I've got on line 19, that's a type annotation. That's just it doesn't really do anything. The type inference will do this for me, but I think it's useful to show what the types are. It makes it easier to think about it and see what's going on. So I could do the same here. So the type of that is just that. That's fine. That type signature might look a bit weird to you. It won't look weird to Lawrence because he's been writing F#. So the first one, well, the first n of them will be the input parameters, and the final one will be the return value type. And it will seem strange to start with, because you'll think, well, what if there isn't a return type? And then you'll think, well, there has to be a return type because of the language. You can't, having a void function doesn't make sense in a language where you're not allowed to do any side effects or any mutation inside the function. So there's always a return value. Your next reservation about it might be that it's weird that you don't differentiate between the input parameters and the return value. It's just a long sequence. The reason for that is because, like F# and like Haskell, Elm does this automatic currying. That's the partial application of functions automatically. Let me just do an aside to explain what I mean by that. If I did the Elm REPL here, if I say I wanted to write a function to add two numbers together, I would add xy equals x plus y, then it's going to return when it gets started. What have you done to it?
Never happened before.
Come back to that. Oh, it's working up. So it's going to return and say number, 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 which means that it takes two numbers and returns a number. But if I do that, it works as expected, 8. But if I do that and I don't pass in the 5, I just get back a function that takes a number and a number. So that's the automatic partial application happening, and it's really useful. You can do it in any language, obviously, but it's really nice that it's built in, because obviously then it allows you to do things like it allows you to do, then if say I want to add 3 to everything in a list, I can just do I can create a new function called add3, which is just add 3, and then I can use that which is nice, because it's going to take the partially applied add3 function and just pass in the other numbers into it, and it's captured the fact that the 3-ness of it has been captured in the function.
How do you do it without if
Yeah, I mean,
stuff or
yes, you could do this. Whoops, yeah. Yeah, that's a nice little taste of what the compiler does for you. Without that partial application, then you would probably want to do it with, you'd have to do it with an anonymous function, which you could still do. But it's just, it's an aside on that. That's why the type signatures look like that. It does make sense.
Sorry, one of the questions. How is the declaration of a model,
Yeah.
the type of initial model, is that really a function from the unit that returns a model?
Yes, that model, the type also serves as a constructor. Is that what you're asking?
So you said initial model is of type model.
Yeah.
But is it really a function which starts with nothing and returns a model.
I don't know. I think at this point, initial model is just a value, obviously because it can't change, and beyond that, I'm not really sure.
Okay. As if you get who inspect the type of say.
Okay, let's try it.
Harrington Haskell, it returns a function.
Let's try. Yes, so it returns. So model returns us a function that accepts an
Yeah.
int and returns a model. Yeah, so it's a function. Okay. So the next thing we're going to need is a function that will update our model in response to something happening. But before we get to that, we need to think about what things can happen. So we'll create another type called action. Generally, these you have a sort of nothing happened, and then we'll have some the things that can happen in our little thing. Will be a
Type continuation.
no, it's not. It's this is a. It's not an enum. It's an enum on steroids.
So discriminated union.
Yes. So although this looks like an enum because these aren't carrying any data with them, it's a description of a type, and they could contain other things. Like I could say, if I wanted to make the blue button do 5 clicks, I could pass along values in there as well, so it would be of a different type. You can put anything you like in there. It just looks like an enum, it's not an enum. So then I'd need an update function which takes one of these actions and then takes one of these, my model, and then sends back to me my new model. That's the type signature. These are all optional again. Don't have to put them in. So that would look like action model, and for now we'll just return the model, and later I will forget I've done that and wonder why it doesn't work. So remember, that's why it doesn't work. So let's just compile.
That's just to get it to compile.
Yeah, just to set this up so that I need an update function of some kind. I've got a view function at the moment, but in reality I want my view function to be slightly different to this. Like I mentioned before, when you actually do any clicks or anything like that, you've got to send a message to an address in order to complete the circle. So the first thing I will need is an address into which I can put actions. The second thing I will need is my model, and what I will need to return is HTML. So now I'm going to get a compilation error. It's going to tell me that it's going to tell me firstly that it can't find that because I need to import signals. And then it's going to tell me that the type annotation doesn't match the actual implementation, which is true. And then the problem now is that I need an address to pass into my view, and I don't have one. And I need a model to pass into my view, and I don't have one. That's where we need to do some wiring. So I'm going to create this thing called an inbox, which is what I'm going to call my mailbox for this thing. And this is going to be a signal mailbox of type action, which means that there's a mailbox that you can put actions on into, and it will expose a signal of those actions. This wiring, incidentally, is stuff that you typically don't do, because there are supports packages that kind of do the wiring for you, but it's quite good to do it from scratch, just to get clear on what's going on behind the scenes.
So is there typically only one mailbox?
No, you can have as many as you like, because you can take as many signals as you like and merge them and aggregate them. But yeah, there's tons of different ways of doing it, but this is one way. So to actually create this mailbox, I have to give it an initial action, because a signal always has to have a value. So we'll start with that dummy action that we created. So now we have an address, because we can just use inbox.address. And we can also pass in a model, because we've got an initial model. And now the compiler should be happy. But it still doesn't work. So what we have to do next is actually handle this click. And we have to make sure that we're displaying what comes out of the model. Second argument to button is an unexpected type. Okay. Is that not? I think it's having a connection problem. I'm going to press on and hope that this. It's not connected. It's it's having a network issue, I think. I don't think I've got any brackets missing.
That one, yeah, that's where brackets.
That's fine. Let's carry on and hope it recovers its connection. So that's yeah, okay, so it's working now. The intention there is that I'm picking up the current state of my model. That's all I have to worry about, what's the current state, and then I have to worry about what to do when I click. And this is quite familiar to start with, similar to what you would do in JavaScript. But onClick, which is a function that comes from the HTML events package, but what it needs to be given is an address, which fortunately we have, and also the type signature of that address tells us what we need to add to it. We need to send it an action, so in this case we're going to send it a blue click. So, bum 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 bum, doesn't do anything. Doesn't do anything for two reasons. One, we haven't actually done that step where we need to fold our stream of actions into a model. So we need to create a model, a signal of models, and we do that by saying signal fold P into our update function. Start with the initial model, and we're mapping over the inbox signal. So there's quite a lot going on in that line of code.
Should it be inbox signal or index signal?
It should be inbox signal. Well done. So what we're saying here, so every time I click this button, I'm dropping a blue click message into the inbox of that mailbox. So that stream of blue click signals is exposed here. I'm folding over that stream of signals, starting with my initial model, passing each action and the previous incarnation of the model into this update function.
Where do we define action? Where so you've got on line 25 update action model.
Yep.
So is action something you declare or?
So
Yeah, it's up
18.
line 18.
Okay, so the uppercase one implies a lowercase thing.
This is the line 24 is the type signature. Line 25 is the implementation. So this is just like an argument to the function. So it doesn't matter what we put here.
Okay.
It's just the first argument. It's a bit, does your head in a little bit. It's still not quite going to work because we need to change our view slightly. So what we need to pass into view.
Do a tab declaration.
Sorry?
Do a tab declaration.
Done again. Inbox dot address. This is where we're going to use this partial application. Because in order to map over my signal of models, I need a function which accepts a model. And my view function is a function which accepts an address and a model. But I can obtain a function that accepts just a model by partially applying the view function with the address, as I'm doing here on line 62. So I can use that, call signal map over the signal of my model. Now if I've done everything right, that's going to compile, and it's not going to work.
Is that because of the deliberate escape on line 26?
Yeah, so everything will be working perfectly except for the update function here, which is not doing anything. So the model never changes. So basically, this is just the only missing ingredient now. I can do pattern matching on my action type to basically figure out what are the different ways that I can modify my model in this app. So I will say case action of no op, then that's the only case where I want to do nothing. Blue click. So if I get a blue click, I want to take my model and I want to create a new model with blue clicks set to that looks a bit weird, but that is how it's done. Now It works.
What if you now passing something which is not in the case?
Okay, if I
So you can pass
if I can't. I can't.
give you a name.
Well, if I said if I tried to pass in something that isn't in the case, it won't compile.
Oh, I see.
Well, if you pass green click,
Well, that's a good question. So
Yeah.
we're going to need to duplicate this stuff anyway to do the green clicks. We would probably tidy this up.
You get compiler warnings at all?
Nope. Whether it's right or wrong.
So there, where that case isn't comprehensible, then you wouldn't be able to tell you.
Yeah, I was a bit surprised by that. I think I might not quite understand that. Oh no. This is what I feared.
I'm on
Bracket 1 after 58.
Where?
is an extra
52 is an extra one.
bracket.
Are you sure?
No, you
An extra one.
Devinder.
I'm really close to the screen.
He's on fire.
He's using-
So, oh, it's not working.
Motion. Yeah, you can't do for action or blue click.
The blue click's not working now.
Oh.
It's worth rolling back to where you were.
Fucking
It's 'cause it-
Devinder stitched us up. Unbelievable. Typical, I might say.
Missing the yeah,
Okay, it is working.
Judy, can you see the source for that?
The source.
Yeah.
The
Uh,
yellow one?
Yeah. Ah.
Hmm?
The errors. Hey. Okay.
Non-exhaustive
One
pattern matching.
time error.
Yeah,
No,
yeah.
it's no wrong time
Actually, it does say in the Elm documentation the only way you can crash it is to do non-exhaustive pattern matching on your case expression. So maybe that is why it's not working.
And it was working.
But yeah,
And
it's-
it is working.
It is working now, yeah.
But it's working as you can click it.
But it wasn't hosted A4 and it
Yeah.
still was working.
Yeah. I don't have an explanation for that. It's Devinder's fault. Is that what you actually wanted to see, or did you want to see what kind of JavaScript it generates?
Yeah, that.
Yeah, okay. Yeah, it creates some pretty hairy JavaScript. Okay, this is working, so let's try and be careful about this. I wanted a whole new div, that's why. And maybe I didn't change that. Okay. Let's just add the other one as well. And there we go. It works. So that's all the main building blocks, and you can nest this as deeply as you like, and all the little bits just behave completely the same way, and then the whole thing cooperates, because you can you know, we've done these mailbox addresses. You can create forwarding addresses. So if I had a subcomponent which just defined its own little set of actions, I can still get it to cooperate with its parent component by using these forwarding addresses.
These are then reusable.
Yeah, yeah. So you could just duplicate this and put them side by side, and it would still work. But yeah, that thing about the incomplete case statement is just about the only thing that ever you can do to make it crash, other than explicitly call debug crash, which does exist and is used for debugging purposes.
Can you have a sort of pull through pattern?
Yes, you can do that sort of thing, but I think it's kind of frowned upon. And then, you know, if you want to sort of change the behaviour, then you're really just messing around with the wiring and not the bits that don't really need to change. Like if I wanted to only update my view every second or something, why do I want to do that? I don't know, but I'm just thinking. So if I wanted a like debounced model, I could. I'm slightly guessing how to do this, by the way. So. We'll need to just make sure that compiles. But then if I so what's happening there? I'm basically saying that I'm creating a new signal. So this is just an example of the ways in which you can combine signals. I'm creating a new signal which just samples the second signal when the first signal has a new value, and that time package exposes some sort of useful signals around time. Frames per second is a very useful one for kind of games development and stuff. It makes it really easy to create a sort of 60 frames per second event loop thing. So if I then just looked at that instead of model, it's exactly the same type, so it won't care, hopefully. And then I can click this like, and it just does it once every second. There's a loads more to it. I did a more comprehensive thing, which let's see if I can get that running.
Can we see? We do some time traveling as well.
Yeah. So this is like inspired by the front end development test that we get candidates to do. We give them a JSON file of hotels and get them to do blah blah blah, display them and allow you to filter them and stuff. I've gone one step further because this is using our actual APIs and also has an autocompleter for the destination. So you can do all the stuff. It's going to be slow, not because it's slow, but because I'm going through my phone. Anyway, ask the API team why it's slow.
It's your phone.
It's my phone. So like again, using this, I've had plenty of circumstances where it's not doing what I expect it to do, but I've never had any circumstances where it throws JavaScript errors or anything. It either works or it doesn't work.
Did you trust the debugging?
Not on this because it doesn't work on my laptop because I haven't installed Elm quite correctly because it's it only has installers for Windows. But we can do it. Can do the interactive one. So yeah, because of the nature of the language, because all of your state is just an immutable stream of data, you can go backwards and forwards to any state in your system.
What happens if you're calling this
exactly. I mean, it's not magic, but if you reflected those changes in the state, your client-side state, then it would still work. So basically, you need to annotate your code a small amount. You need to tell it which bits of data you're interested in watching. But then from that point onwards, you can just you can trace certain properties. So that reason I'm getting that bouncing thing is because I'm tracing that. These things here on the right are the things that this program has told it to watch. And then this is the timeline of signals. So basically I can pause that and then I can just drag it backwards and see my little Mario.
Is that yours? Is this your program?
No, this is one of the examples of the time traveling debugger. So you can just move backwards and forwards throughout the stream of your app state, and you can see whatever values you want or you're interested in.
So when you're running it actually in production or whatever, then does it hold all states forever while it's running?
Well, this is one of the questions that Christina was asking. Basically, doesn't it just run out of memory and stuff like that? I don't have a PhD, so I don't know why it doesn't, but it doesn't. I'm reliably informed.
It will. It has to. Well, you just won't be able to go back. You just won't be able to go back in time all the way.
Yeah. So I mean, because the stuff's like immutable, it just probably uses the tricks of snapshots and memoizing so that it doesn't actually have to recalculate. I don't think it's lazy like Haskell, so it doesn't have that problem. So in Haskell FRP, there's a problem that if something isn't evaluated for a long time, because Haskell does everything lazily, you come to a point where you finally evaluate it and it just takes forever because it has never evaluated it before, and all of the computations that involves get done all at once.
My understanding is that it's clever about immediate editing. So when you create a new object, it isn't really an entire new object. It's the old object, but with the new bits.
Oh yeah, it does that. Persistent data structures is one thing that mitigates your sort of knee-jerk reaction to functional style.
Presumably it's only storing signals. It doesn't need to store anything else because they're all constructed from the signals.
Yeah. There are academic papers galore on this subject, which I can refer you to. I certainly didn't understand them, but maybe you will. And so I asked the guy who wrote this language about this topic, and he pointed me his PhD thesis on functional reactive programming and told me to read it and sent me to some. That makes him sound like an arsehole, which he's not actually. He's a thoroughly nice fellow, but yeah, it was a bit over my head. But it's definitely very clever.
How widely adopted is it?
Not very, I don't think.
Is it gaining? Presumably it's gaining traction. Isn't it?
There are a couple of people using it in production, and obviously they love it. It's
a couple of the actual
I don't know. So on the subject of should we do this, it's another sort. It's on the Jelf's tech radar. It's definitely on trial. I think it has some major selling points, but as you can probably,
it's not on ThoughtWorks tech radar.
As you can see, it does take a bit of getting your head around. It's quite alien. It's really restrictive in some ways, but that stops you making mistakes. It just turns it upside down. Like you spend all of your time thinking about what shape your data should be and how it should interact with other parts of your app, and getting it to compile. That's where all the effort goes. and you spend no time debugging it at all because it generally works. It's just a different approach, and I guess if you absolutely cared about your code being totally bulletproof in production, it would be a good choice. But you're not going to find very many people who know how to do it.
How does one write this code?
Easily. I have written some tests.
Especially the JavaScript style if you want.
Well, I mean, it's easy. You can just load the REPL, import your module, and run the functions. There isn't much in the way of a test framework, which I thought was weird to start with, but actually now it's because it's trivial. It's just they're all immutable functions. There's nothing going on. There's no tricks up its sleeve. So you just write some functions to run your functions, and that's it. I have done a bit of it just to sort of convince myself that it's okay. There are test frameworks, and it's fine. There's a whole load of other stuff to go into, like how it handles asynchronous code, how it deals with it. It's got a whole package about tasks and effects for doing async stuff, like both HTTP requests and even animations. But I didn't really want to get bogged down in all that partly because I only half understand it myself, and partly because it would just cloud the real fundamental stuff about how it works.
Does it run on some VM or anything like that?
No, just transpiled to JavaScript, but I think that they have plans to make it compile to other things as well, so you could use it on the server, particularly initially for the purposes of server-side rendering, which all of the other frameworks are starting to think about. You can. It's got quite a good potential for sort of easing into it, because you can. If you look at the source here, where is the JavaScript? So it's that Elm full screen thing. It's just telling it to just basically take over the whole screen and run this Elm app. You can also attach that to an individual DOM element, and you can use these things called ports, which are another concept in Elm, and that basically they can be used to talk to JavaScript and receive messages from JavaScript. So it's very easy to embed a small bit of Elm in your existing app if you want to. But then there's lots of other things to consider, like what sort of size JavaScript it creates and that sort of thing. If you have a look at this, which is a bit more representative of something you might do. Have I switched off the... This is the JavaScript that it generates. And it's utterly incomprehensible, which is fine. And it's a bit on the chunky side, but it's not too bad. It's not uglified and compressed in any way. I think you would probably at least halve that, if not more. But it depends. I mean, you wouldn't want to sort of take that hit in addition to all the other stuff we're already doing, probably, but depends on the application.
So is that some sort of logarithm for the size of the JavaScript generates? I mean, for a small program generates?
Well, no, I suspect that mostly this is the Elm runtime, and that the rest of the stuff that constitutes the logic of your program is going to be pretty small.
Oh, so more or less they'll be about that size, regardless.
Yeah, I'm guessing, but when I look through this, I can't recognise very much of it as my code, so actually any of it, let's be honest.
That probably depends on what's included in your application. So
The build tool is supposedly got some intelligence, and it will only build in the bits of the Elm runtime that you're using, and I'm sure that they'll be working on improving that.
Can we see the size on your other app?
This one.
The one we just created, yeah.
I don't know if we can really. Might fucking right click would work. Might be able to. I don't know where it puts it.
So if you go to your network tab and press revive again, will you not get a new request and be able to see
Yeah, maybe. Maybe. No, it's
You're
just.
in XHR.
What's in your
Is everything
Yeah.
Yeah, that's.
129k.
What's all this stuff?
Now, can you add?
That's from the first set.
We can try importing a couple of more things into your program, and then see if that size goes up.
Yeah.
Yeah, because it's still not used.
So what would the role of exposing is what it presumably to reduce the amount, the size of the library
Can you clear it and then start again?
So it was 129 last time, wasn't it?
well, yeah, it could.
Oh no, I just
press F5.
just pressed F5. It's all gone.
So that should be there.
It is. The role of exposing is yeah.
Is Elm website built in Elm?
129.
Or is it
Yeah,
just
same
Elm?
size. Yeah, I'm not convinced that the Elm Make build tool does a great job at the moment, because I've seen stuff in my build file to do with all the sort of 2D graphics and colour and stuff, and I'm not using any of that. So there's quite a lot of hope that they can improve that, and maybe it will get down to a much smaller size. But it's not massive as it is. I think it's quite viable to use, especially particularly on admin tools or whatever we could use it. But really, I'm not hopeful.
So what are the drawbacks? What do you think is sort of a downside of this approach?
The downside is that it's quite a learning curve for people. People will see the constraints as a problem, and they won't be able to get their heads around the fact that it's all deliberate. It's
Yeah, no, I meant other than that, like that's if you're learning a new language, it's probably obvious. But
well, I don't think there are any downsides to it. I think we probably need to look into a few more proof of concepts to make sure that we're not going to have any sort of massive roadblocks with it. But this example I've done, I think, is much of what we need to do. Just more of this sort of thing.
SEO again,
Sorry?
search engine optimization.
It's no worse than any other client-side
Or
thing.
so we still need that pre-rendering that guys.
Yeah.
Is that
you said it's no worse, but you also said it's very restrictive.
No, it's no worse in terms of SEO optimization.
Yeah.
Performance compared with
Performance is
really good.
to do MVC benchmarks is really good.
Sure you showed us
And it should be. I mean, that's one of the points of the way it's written is with performance in mind.
Then is it easy to use with some other JavaScript, libraries? So say you've got a library to draw graphs,
Yeah.
and you want to use it to prepare the data for it. So
Yeah, you can.
at the end you want to
You
know.
can. You use ports to basically interop with existing JavaScript in both directions, and basically that takes care of translating it into stuff that Elm understands.
You put tags
But how
on the
does it
ports.
handle the build when you use an external JavaScript library?
You put tags on the interface.
I don't know. I haven't done that much of that, to be honest.
How's the browser support?
I don't know. I think it should be fine because it's just generating normal JavaScript. I mean, it's complicated JavaScript, but it's normal JavaScript. I don't think it's doing anything wacky because it doesn't need the JavaScript to be all fancy and immutable because you don't write it. I mean, if you go digging into it with the console, you can probably still mess it up. But it's I mean, it's exactly the same approach with TypeScript. You can still screw it up. It's just going to prevent you screwing it up until you've compiled it. And you know, you're not trying to shoot yourself in the foot. So as long as you listen to the compiler, you'll stay out of trouble. I think. I think it's cool. I think it's much more interesting than any of the other web frameworks that are around at the moment. But then I always think that.
If you go back to your example with the colorful buttons.
Yep.
So if you want to have something like a total clicks,
Yep.
you said we can actually get another mailbox and forward messages to this mailbox.
Yeah.
So practically you will forward all the messages to the mailbox and then.
Well, if I wanted a total clicks, the information is already there. I would just write a function to add the clicks together in my model.
Okay. And then I was more thinking about something like a pops up with the mailboxes.
Yeah, that's what it is, really. Yeah.
Okay.
It is pretty similar to that, except that the end result is just exposed as a signal. So I think that's all I had. I mean, obviously there's more stuff we could go into, but we're over time anyway. But any other questions?